In this video, we're going to talk about the rock cycle, which we use to describe how one type of rock can become another type of rock. So we're going to start by reviewing the three types of rocks and how they're formed, and then we'll talk about the different processes that turn rocks into other kinds of rocks. I'm going to use markers to kind of color code my notes. If you have colored pens or if you have colored markers available, I would suggest that you do the same. Okay. We're going to start with these three circles in the middle that describe the three types of rock. So I'm going to zoom in just a little bit. Okay. So if we start at the top, we're going to talk about igneous rock. I'm not going to do any coloring right now. I'm just going to write and fill in the blanks, but you're more than welcome to come back at the end and color the doodle notes, color the different spaces, and make them your own. So igneous rock is created from the cooling and solidification of lava or magma. Remember, solidification just means turning to a solid. So it's where the liquid, lava, and magma turn into a solid. Lava is what we call it once it has reached the Earth's surface. If it's still underneath the Earth's surface, we call it magma. The rock's crystal size depends on how quickly it cools. If it's lava above the Earth's surface cooling very quickly, the crystal sizes are much smaller. There's not time for the rock to develop those crystals. And if it's underneath the Earth's surface where magma is cooling, it cools more slowly and it creates larger crystals. I'm going to move to the bottom left and talk about sedimentary rock. Sedimentary rock is created. Sedimentary rock is created from the deposition of sediments in layers over long periods of time, and sedimentary rock often contains fossils. The third type of rock we've discussed this week is metamorphic rock. It's going to go over here. Metamorphic rock, remember morph means to change. So metamorphic rock is when existing rock is subjected to very high heat and pressure. This usually takes place deep underground. Okay. Now that we've talked about the three types of rocks, we need to look at the processes that take place that change the rock type or that create the rock that we've talked about so far. So I'm going to scoot it down a little bit. Up at the top, a lot of those processes are involved in the formation of sediments. Many of these words should sound familiar from what you just did at pit stop A in this stop number 2, but it's good to see those definitions again. Okay? So we talked about sediments as being the base of the sedimentary rock, when sediments get pushed together and stuck together and basically glued together. But how we get those sediments involves quite a few processes. So coming up here to the top where it says formation of sediments, weathering we described as the breaking down of rock into sediment or smaller pieces. Here it says sediment is the creation of smaller pieces of rock through physical or chemical means. Sometimes that can be through wind or ice, water, okay, or chemical things like acid rain breaking down rock. When that sediment is moved somewhere else, somewhere from the original starting point, that is called erosion. It can be moved or eroded by wind, water, ice, gravity. Think about like a landslide or a mudslide. That would be gravity. If it's put into a new place or deposited somewhere, we call that deposition. Oftentimes we think of these three in a process: weathering, erosion, and deposition. The rock is broken down through weathering, it is moved somewhere else through erosion, and it is put into that new spot or deposited through deposition. The last part of the process, when the sediment is squeezed together and then glued into a new rock, we call that compaction and cementation. Think of it as cement. Many of these processes over here, along with some of the other ones that you looked at, are what is going to go in these arrows down here that leads us from one rock type to another. Since it's a cycle, it's almost like it's never ending. You can choose one spot and make your way around the circle, or in this case the triangle. So I'm just going to choose to start with the sedimentary rock, since that's kind of what we've been talking about with the different sediments. If sedimentary rock underground reached temperatures where it was melted and it turned back into that liquid, okay, then that liquid then was able to become a solid again. We would combine two processes, and we would say that is melting and cooling. That's what's going to lead us to igneous rock. So first the existing rock has to melt into that magma, and then it has to cool and harden back into igneous rock. So in this arrow, I'm going to write melting and cooling. So first it melts into magma, and then through the process of becoming an igneous rock, it is cooling. If that igneous rock was exposed to extreme heat and pressure, it could turn into a metamorphic rock. So on the arrow from igneous to metamorphic, I'm going to write heat and pressure. If that metamorphic rock, in order for it to become a sedimentary rock, it would have to go through these processes, kind of like we talked about over here. It would have to be weathered into smaller pieces, eroded and moved somewhere else, and then deposited in a new spot. So on the arrow going from metamorphic to sedimentary, we're going to try to squeeze in here. Weathering, erosion, and deposition. If you can't fit all that and you want to write WED, as long as you remember that WED is weathering, erosion, and deposition, that is okay. Now, we also said that sedimentary rock, not only could it form igneous rock by melting and cooling, but it can go back to a metamorphic rock. Always, to get to metamorphic, what we'd have to go through is extreme heat and for a metamorphic rock to go back to an igneous rock, just like when the sedimentary rock went that way over here, we would have melting and cooling. So melting and cooling. And then for an igneous rock to become a sedimentary rock, it would have to go through those three processes again of weathering, erosion, and deposition. Again, if you have to write WED to get it to fit, that's fine. One observation, notice that the arrows going to igneous both say melting and cooling, because the rock would have to be melted into magma and recooled to form igneous rock. Both of the arrows going toward sedimentary rock say weathering, erosion, and deposition. That's how rocks are broken down and recreated as sedimentary rocks. Both of the arrows going towards metamorphic say heat and pressure, because it's heat and pressure that cause the other types of rocks to change into metamorphic rock. Again, it's a cycle, so it doesn't have to go in a certain order. And if you notice in the middle, it says, with a big exclamation point here, meaning it's important, any type of rock can become another type given the right conditions. So depending on what processes or what conditions the rock is exposed to, that's what determines how it will change. The last thing I want to do on here is come up to the top where it gives us some examples. Okay. Sedimentary, I'm going to go back to my blue marker. Examples that we've talked about, sedimentary rock, include shale, we've talked about coal, I'm going to write sandstone. Some of these we've seen before, others are new, but write these down. The more we have in our notes, the better off we'll be. For metamorphic, I'm going to go back to my green marker. Examples of metamorphic, I'm going to put marble, remember that was non-foliated, schist, S-C-H-I-S-T, and gneiss, remember that's spelled G-N-E-I-S-S. Lastly, for igneous, I'm going to go back to my red marker. For igneous, I'm going to write pumice. That was the one that had a lot of the air bubbles inside. Obsidian. And I will put granite. I think we remember that from the countertops. Okay. When you're done, if you want to go back and color in the spaces, you can. Then cut the extra white space outside. And these are going to go onto page 9 in your journal. Again, cut out the square, the rectangle here, get rid of the extra white stuff on the outside, and glue